what did we understand? So we had wires, straight wires, and there were three things. So one was that we had a finite wire, right? And let's say this is theta 2, this is theta 1. So we calculated the magnetic field at this point. This was r distance. So magnetic field was mu naught I by 4 pi r sine theta 1 plus sine theta 2. This was for finite one, right? And direction was inside, right? Because this is in the right, this is the current, this is the current. So direction was using the Maxwell's thumb rule. So direction was inside, right? This was the current which is flowing, and we are calculating in the right hand side. So if we place our thumb in the right hand side, if we curl our finger, this is going inside. So that is how we got the in the right hand side, that would be inside, right? Right, Tariq? Second thing
Yes,
we
sir.
understood, yeah, second thing we understood that if we have a semi-infinite wire, right, this is R, and we have semi-infinite wires, this is infinity. So for that case, we calculated the magnetic field. This was mu naught I by 4 pi r. Right, and again magnetic field was inside. Magnetic field was inside. So this is for the semi-infinite wire. And then we saw the third case, which was the infinite wire. So for infinite wire, we calculated the magnetic field, which was again inside. This was mu naught I by, oh, this is not 4 pi. So, yeah. So this is 2 pi r. So these were the three different magnetic fields. And the fourth one is that if I calculate the magnetic field at this point, along the line of the wire, so at here, right? Let's say this is A point. So magnetic field at A point would be 0. So these are the four things that we should remember, right? And in the homework, I gave you this problem. So this was the homework that I gave. So let me just take this. Take this one and let us understand this question. We have this problem, right? So the currents are same, right? And we want to calculate the magnetic field at this point. So we want to calculate the magnetic field at P point, right? So for this one, what kind of wire is this? What kind of wire is this? Yes. What kind of wire is this? So
Yes, sir.
we have this wire, right? We have this wire, one wire which is OY, right? One wire which
Yes,
is
sir.
OY, right? So we have this thing.
Sir, is it infinitely long?
Yeah, so one thing is infinitely long, right?
Yes.
This part is,
And this is finite.
yeah, this is finite. So, okay. So this angle is theta 2. This distance would be how much? Let us part by part calculate. So this distance is how much? Yes,
Theta 2.
distance, this distance. This is point x comma y. So this distance is x, this distance is y, right? So this distance is how much? How much is this distance? How much is this distance? Sorry. So this is x, right? This is x. From here to here, this point, let me just write. Okay, so let me write it. So you have this x and y axis.
Yes, sir.
Yes, Tariq. Yeah. So you got it right. Now can you hear me? Can you hear me now, Tariq?
Yes, sir.
Yeah. So let's say that I choose this point P, and the coordinate of this point is x comma y. So which means that how much is this distance? This is
Yes.
x. So this is x, right? How much is this distance? How much is this distance? Yeah. How much is this distance? This distance is x, so this distance is how much? This is a coordinate point x comma y, right? So which means that we have moved x distance in x direction and we have moved y distance in y direction. So this distance is y. Is that clear? Is that clear? Is that clear, Tarif? Yeah, is this clear? Is this clear, Tarif? I'm not. Yeah. Oh, Chavez, you have. Yes, Shaved, Assalamu alaikum. You are late. Yes, Shaved, and yes, Assalamu alaikum, Shaved. So,
Walaikum salam.
yeah,
You can hear me?
yeah, I can hear you. Yeah. Yes, Tarif, can you, is your mic working fine now? How's your internet?
Yes,
Tarif?
sir. Can you hear me?
Yeah, I can hear you. Okay, so let me
Sir,
just, yes, Shaved.
I couldn't join last class because I was not well.
Oh, you were not well. Yeah. Okay, so what happened? Are you okay now?
Sir, basically I was having a serious migraine, but now I'm okay.
Oh, yeah, so mic. Yeah. Now you are okay, Alhamdulillah, so which is good. Yeah. Okay. So let me just recap what we understood in the last class. So I will just tell you that we understood that what would be the magnetic field of a finite wire. So we have a finite wire, right? And the current is flowing, which is I, and these are the two angles. So we want to calculate the magnetic field at this point. So that is given by this, right? And we can also have this semi-infinite wire. So for semi-infinite wire, this is the magnetic field, and for an infinite wire, this is the magnetic. And if we calculate the magnetic field along the line of the wire, so this would be zero. So these are the four basic things that we have understood. And now we are applying that. So we have this question. So we have two wires. One is this wire, right? And the other one is this wire. So we have this thing. This is wire one, and we have this thing which is wire two, right? So we are separately calculating the contribution of each wire. So let's say we are taking this OY wire, OY wire we have taken, and we want to calculate what is the magnetic field. So that is what we are doing, and we were discussing that what are these distances. So for this wire, this point is situated at x distance because this coordinate is x comma y. So this is x distance, this is y distance. So if I take this wire, so for this wire, this is my x distance. So
Sir,
yes,
we have to find the magnetic field at point B.
yeah, we have to find the magnetic field at a point. So this is what we have to do, right? So we will assume that this is a finite wire, and we will put the conditions of these two angles, and then we will see that what is the value. Right? So this is what we have to do. So we have this wire, we have these two angles, theta 2 and let's say theta 1, and this is the point that we are calculating. So we already know that this distance is x, and the current is flowing, which is capital I guess. So if we apply the finite wire thing, right? So what is this angle for this infinite thing? For this infinite thing, what would be the second angle?
90 degree.
90 degree, right? So one angle is 90 degree and the other angle is theta 2. So if I apply that thing, right, let me erase this part. So if I apply that thing using the finite wire thing, so this is x distance, and we are calculating in the right hand side. So if we use the right hand thumb rule, so this would be cross. So let's say this is wire 1. So magnetic field due to wire 1, right, at P, this would be mu naught by 4 pi, distance is x, and sine theta 1 plus sine theta 2. So for our case, this theta 1 is 90 degree and theta 2 is theta 2. So this would be how much? This would be mu naught I by 4 pi x. This is 90, sine 90 is 1 plus sine theta 2. And remember, this is B cross. Let's write this as 1.
What is B1?
What is P and what is what?
B1.
P1. Yeah, so I have written that this is due to one wire at P point. Magnetic field due to wire 1 at P point. So let us simply write that as simple notation. Let us write that P1. Right. This is P1. And direction is cross. So I will write B1 and I will write the direction as cross. So this is showing the direction. Okay, is this clear, everyone? Tarif, is this clear?
Yes.
Okay, so this is one part. And for wire 2, you have this distance, which is y. This angle is again, let's say theta 1. So if I write this part in here, this angle is theta 1 and the other angle is again in right. So theta 2 is 90 degree, theta 1 is theta 1. So if I again apply and you see that, yeah, so this is the wire. Current is flowing like this. So if I put my thumb in this direction and I curl my finger, so what is the direction again? Inwards, right?
Yes.
So I will again get the same direction as this one. So
So,
magnetic,
sir, this will add up.
yeah, so this will add up. Absolutely correct. So V2, this would be mu naught I by 4 pi. This distance is y and sine of 90 plus sine of theta. So this is mu naught I by 4 pi and this is again cross. So 4 pi y and 1 plus sine theta. So again, as Chavez is saying that both have the same direction. So B net would be B1 plus B2 in the downward direction. So this direction would be cross. This is B1 is how much? B1 is mu naught I by 4 pi x 1 plus sine theta 2 and B2 is mu naught I by 4 pi y and this is 1 plus sine theta 1. So these are the things that we have to figure it out, right? So we have theta 1 in this triangle, right? This is theta 1. This distance is y. This distance is x. And this is the hypotenuse. So in triangle OP, let's say M. In triangle OPM, this is the triangle that we have. OPM. This is y, this is x, this is theta 1. So this is hypotenuse, right? Oh, who got disconnected? Yeah. So this hypotenuse would be how much? Root of x square plus y square. Right, guys? Right. So what would be sine of theta 1? What would be sine of theta 1? Yeah, what would be sine of theta 1? remember sine theta is P by H, right? For this theta one, this is base, perpendicular is x. So x by root of x square plus y square. So this is sine theta 1. And for sine theta 2, we have to figure out sine theta 2. Right? So what is the triangle? This one is the triangle, right? So this is the triangle. This is theta 2. This distance is x. This is y. Again, this is hypotenuse, which is x square plus y square. So what would be sine theta 2? Tarif and Chavez, you guys tell. What is sine? Yes, what would be sine theta 2, Tarif? Yes, what would be sine theta 2? Again,
X by X P
P by H. For
yes, sir, P
theta
by
2, what is perpendicular for theta 2?
Y.
Y, right? So y is perpendicular because whatever angle is making, so this is the base. So y is the perpendicular. So y by hypotenuse is. Is that correct, Chavez? Is that clear, Chavez and Tariq?
Yes, sir.
So we have sine theta 2,
Can
we
you hear
have,
me?
we have sine theta 1. So we can put all these values in here. So let us put these values. So B net, this would be mu naught I by 4 pi x, 1 plus, what was the, 1 plus sine theta. So 1 plus y by root of x square plus y square, and plus mu naught I by 4 pi y, 1 plus x by root of x square plus y square. So these are the things. Then we have to solve this one. So what are common? Mu naught I by 4 pi. That is, yes, mu naught I by 4 pi.
We are
This is,
taking this in terms of y and x.
yeah. So this would be, and let us I take this one inside. So 1 by x plus y divided by x square plus y square. This is 1 by, so this would be x, right? And this is 1 by y plus x by y root of x square plus y square. So this is right. So if I take the LCM of this thing, if I take the LCM of this thing, so how much will I get? I will get x, y, and x square plus y square. So this is the LCM. If I divide this by this, then so then I'll get y root of x square plus y square. And if I divide this, so I will get y square. And if I divide this y, so I will get x square plus y square. And if I divide this by y, so this is x square. So this is what I will get, right? So if I write them separately, so I write this one and this one together. So x square plus y square divided by xy root of x square plus y square. And then I write them together. So y, and I can take this common. x square plus y square is common and this is x plus y. So divided by xy root of x square plus y square. So this will cancel out, right? And I know that this xy I can take common. So mu naught I by 4 pi xy. And this would be, this will cancel out and this would be root of x square plus y square. So this is root of x square y square plus x plus y. So this is the solution. Is that clear, guys? Is this clear? Is this thing
Yes,
clear?
sir.
Yeah. So what is the out? So I have not written the option. So that would be the correct, right? So you guys please note it down and then we'll do another question. Please note it down and if you guys have any doubts, please ask. Please note down this part. Note down the question. Just note down the diagram. This diagram you guys note it down and then note down the question. So remember, we have to get this figure. Whatever is the question, we have to get this figure. If we have got this figure, then the answer is simple. Then we can put theta 1, theta 2, and then we can solve. Yeah. So whenever you guys,
So
yes,
figure is for wire one.
yeah. Can you scroll up or down?
No, that figure you told that that is for wire one.
Yeah, this one, this figure, this figure, this figure you are talking about.
Oh, okay, sir.
Yeah, got disconnected. Sorry, sorry, sorry. Got disconnected. Yeah, so we have to remember these things and then the question solve. So next problem I will take off a triangle, right? And we will try to understand that what would be magnet. So in this chapter, we have you have to calculate the magnetic field due to straight wires, and then you have to calculate the magnetic field due to circular wires, magnetic field of a solenoid, magnetic field of a toroid, and do we have any other thing? Magnetic field of a thick wire. So these are the 5 things that we have to do. Are these 5 or 4? What is yeah, did you note down this part, Shavi?
Yes, sir.
Yeah, so please note down this part. How much you guys have noted? Whenever you guys want me to scroll down, please tell. What time? What? Yeah, whenever you guys want me to scroll down, please tell.
Sir, can you scroll down?
This portion you guys have already done. Yeah, whenever you guys have noted it down, please tell.
So for Bnet, we don't directly cancel nu I by 4 by x.
Yeah, which thing we don't cancel?
Bnet.
B mu naught by 4 pi. Yes, mu naught by 4 pi. You are telling me to cancel these out. Yes, yes, Tarif, what did you say? Yes, mu naught by 4 pi, how can we cancel this thing, right? There is no mu naught in downstairs, right? In denominator,
Okay, so okay.
yeah. So we can put the value of mu naught by 4 pi, right? That is 10 to the power minus 7, but
Yes, sir. So for V2, I wrote it as x, I didn't write it as y.
hmm,
Sir, can you scroll down?
something.
Sir,
Yes,
sir, if possible, can just send the notes of this chapter, like till where you did. because I was absent last class.
Yeah, so up to this part, because yeah, we didn't do that much. We only understood about the magnetic field due to straight wires.
Those are that formulas.
Oh, those formulas. Yeah, so I will send uh, and I will send you guys some homeworks. Please try those questions, right? So
Then is going on.
when you guys will try, then you guys will understand, right? That way you guys can learn more if you guys yourself try this question. Is whenever you guys have noted down, please tell me. Then we'll do the next.
So doing so.
Then, Tariq, what about you? Noted?
Last one.
Yeah, so the next question is this triangle right? We have that triangle. Yeah, this
Someone can you show that
which thing?
in the previous question?
Previous question. So this was the previous.
So
This was the previous question.
yes, so this one last part.
Oh, last part.
Yes, certain.
Okay, so the next question is about the triangle, right? So we have this. So a current is flowing through a triangle of side 9 centimeter each, right? So we have a triangle, equilateral triangle, and the current is flowing in this line. So again, what kind of a wire is this? What kind of wire is this?
Infinite.
Finite wire, right?
Oh,
From
yes,
here to
finite.
here, from here, let's say this is A, B, C. So
Yes.
from AB, this is a finite wire. This is again CA is finite wire, BC is finite wire, right?
So there are
So
three.
yeah, so there would be three contributions, right? One from this one. So let's say this is I. This is I and this is I. So we have to calculate at the centroid, right? We have to calculate the magnetic field at the centroid. So what do we know? What do we know? We know that this is the distance
Theta
that
1
we
and
are. Yeah. So this is theta 1. This is theta 2. So how much would be this thing? How much would be this thing? So you remember this is this right. So all these angles are similar because all these sides are equal. So this is 120, this is 120, this is 120. So if I take the perpendicular, so that would be half, right? Because this is a
yes,
centroid, so these are meters, right? So this would be 60, this would be 60. Is that clear, everyone? Is that clear, guys?
Yes, clear.
Yeah, so this again would be how much? This would be 60, this would be 60, right? Because this angle is 30, this angle is 30, this is 90, so this would be 60, 60. Again, this angle would be 60, this angle would be 60. And we have to figure out what is this distance, right? So how can we figure out this distance? How can we figure out this distance? Yes.
Pythagoras.
Pythagoras theorem, right? So this thing and this would be, let's say this length is how much? 9. So this would be 9 by 2, right? And how much would be this thing? Or let's say we want to find out this. So we have this triangle. Okay. This angle is 60. This angle is 30. This is 9 by 2. So can I find out this thing? Can I find out this thing?
Yes,
Yeah, using the trigonometric ratios, right? So let's
sine
say,
30.
yeah, so this is if I choose this angle, or sine 30 you are saying. So sine 30 would be perpendicular
No,
by
sir,
height.
it's cos.
That this, yeah, cos 30. Cos 30 is correct one. So cos 30 would be base. Oh, why? No, no, no. So again, this
Sir, tan.
yeah, tan. So this is perpendicular. This is base, right? So tan 30 would be perpendicular by base. So this is 1 by root 3. This is P, which is we have to find out, and B is 9 by 2. So P would be how much? P would be 9 by 2, and so this would be how much? So this would be, this is 3 into 3, so 3 root 3 by 2. So this is the distance. And all these distances would be similar. So this is again root 3 by 2. This is again root 3 by 2. Right? Is that clear, everyone?
Yes,
And if we use, so if we use the right hand thumb, so one current is going like this. So this is our thumb. So in the right hand side, what would be the direction? What would be the direction, guys?
outwards.
Outward. Okay, how did I? Okay, let me check. So this is going like this. If I point my thumb in the current direction, in AB direction, my thumb is in AB direction. If I curl my finger at, let's
Sir,
say,
inwards.
inwards, right? So for this one, this is inwards. And for BC, what is the direction? What is the
It's
direction?
inverse.
That is again inwards. And for CA, what is the direction?
Inverse.
Inwards. So all these three will add up, right? So B net would be B1 plus B2 plus right, and we see that angles are same and this distance are same. So B1 would be equal to B2 would be equal to. So I can write this as 3B1. Is that clear, guys?
Yes.
So this would be B1 would be how much? Let us draw this thing. So we have a finite wire. This current is I. This point, and this is 60. This is 60. This distance is, let's say, A. So B1 would be mu naught I by 4 pi A, and sine 60 plus sine 60. So this is mu naught I by 4 pi A is how much? A is 3 root 3 by 2. And this is root 3 by 2 plus root 3 by 2. So this is 2 root 3 by 2, which is right. So this is mu naught I into 2 divided by 4 pi 3 root 3. This is 2 root 3 by 2. This one cancels, root 3 cancels, and mu naught by 4 pi, and 2I divided by 3. This is the value that I'm getting, right? And B net is how much? 3B1, right? So B net is 3B1. So 3 into mu naught I by 4 pi 3 cancel. Mu naught by 4 pi is 10 to the power minus 7. 2 into I is how much? I was 1.5, right? So 1.5. So this would be how much? 3 into 10 to the power minus 7. And this is in centimeters, right? So I have to, oh, this is current ampere, right? Yeah, this was in centimeters, right? So this we have to be very careful that this is 9 centimeters, so we have to write it in terms of meter. So 1 by 100, right? This is 3 root 3, yeah, 3 root 3 by 2 into 100. So this is 100. This is 100. So 100, so 100. So 3 into 10 to the power minus 7 into 10 to the power 2. So 3 into 10 to the power minus 5 Tesla, and inverse. How do we represent inverse? Cross. This
Cross.
is this is B. Right? Is this clear, everyone?
Yes.
Okay, so please you guys note it down, and if you guys have any doubts, please which option would be correct? Whenever you guys want me to scroll down, please keep. Whenever you guys want me to scroll down, yeah. So why I have taken this direction? Because the current is flowing clockwise. If this would have been anti-clockwise, then what would be the direction, guys? If the current would have been anti-clockwise, so what should have been the
From
that
B
would be,
to
yeah, then would be outside, right?
yes, sir.
Yeah, that is, so this part is very important, right? Okay, whenever you guys want me to scroll down, so just write the question and decide, just write the solution. Output, yes, yes, sure, that is. So whenever you guys want me to scroll down,
So can you scroll down?
Whenever you guys have noted it down.
Certain, sir.
Done. Okay. Sorry, what about you?
Yes, certainly.
Now let us understand one thing first, and then we'll do the question based on that. So the next thing is that we talked about the straight wires. The second part is circular wires, right? So using the Biot-Savart's law, we can also calculate the magnetic field of a circular wire. So let's say we have this wire, right? And let's say the current is flowing like this. So if we want to calculate the magnetic field at center, right? So how do we calculate? And remember that this is clockwise. So in this case, in the previous case for the straight wire, we put our thumb in the direction of the current. But now in the circular wire, we will put our four fingers, right? We curl our fingers in the direction of the current. So that is the different. In the case of straight wires, we put our thumb in the direction of the current. But for the circular wire, we curl our finger and whatever direction his thumb is pointing out, so that would be the direction of the magnetic, right? As yeah, for example, in this case, if we curl our fingers, so the magnetic field would be inside at this point, right? And how much is that? So I'm not going to, we use Biot-Savart's law to prove that. So I will directly write that magnetic field would be mu naught I by 2 1, right? And this is the full circular wire, full circle. And then we have, and then we have semicircle. So for semicircular wire, right? At the center, the center, right? Let's say this is R, this is R, and this is like this. So again, magnetic field would be cross, and magnitude is how much? Mu naught I by 4. That is the magnetic field. And for the case of an arc wire, right? For the case of arc wire, what is the magnetic field? So let's say this is the arc, right? This is the center. So let's say this is making an angle theta. So the current is flowing like this, and I take a small line element dl. So the current is flowing like this tangentially. This is perpendicular, right? So if I use the Biot-Savart's law, that would be I dl sine theta
Sir,
divided.
can
Yes,
you scroll up?
yes, I will give the time to note it down, right? I will give you the. So mu naught I, what is the Biot-Savart's law? Mu naught I dl sine theta by 4 pi r. In our case, that is r, right? So sine theta is the angle between dl and r vector. So this is 90, so this is 1. So magnetic field is just the integration of pi dl 4 pi r square. So if we integrate this thing, right? If we integrate this thing mu naught I, all these are constants. This comes outside integration of dl. So dl is going from this to this. This is the arc length, right? Integration of dl is the total arc length. And how much is the arc length? That is theta by 2 pi into, let's say, into 2 pi r, right? So this would be how much? This 2 pi will cancel. So this is theta. So mu naught
Sir,
I.
what will be integrating sin theta?
Yeah, sine theta is the angle between. What is this sine theta? Sine theta is angle between dl and r vector.
So it's 90 degree.
Yeah, so this is 90 degree, right? This is r, this is dl. So this is 90. So sine 90 is 1, right? So this part goes out. And then we have this mu naught I dl 4 pi r square. All these are constant. I have only dl. So dl is r theta, right? So this would be 4 pi r square. So this will cancel. So magnetic field for an arc length is mu naught I theta by 4 pi r. That is the magnetic field of an arc y, right? So this is the wire, and these are all circular wires. So you guys please note it down, and I will directly write down the other things: solenoid, toroids, and the thick wire. So I will write those results directly, and then we'll do some question based on that. So you guys please got disconnected. Sorry for so you guys please note it down, and remember we are calculating all these magnetic field at center, right?
Sir,
Yes,
is there a case where there is no center, like
this
other than the center?
other than the center, yeah. So we have these. Okay, yeah. So we have these things which are called. We have this circular wire, circular rings, and we calculate the magnetic field at this axial points, right? So we have this radius which is r, and we calculate at x distance. So magnetic field at this axial point is how much? Mu naught I r square divided by how much? 2 pi and r square plus x square power 3 by 2 in the x direction, right? In this direction we have magnetic. So y portion cancels out. So this is at the axial point. And you can see that if you choose your x to be 0, because for the case of first for the case of, yeah, so there should be something else. This is not 2 pi, this is only, right? Okay. So you can see that for the case of yeah, for the case of x equals to 0 at center, what would be your x? At center, what would be your x? Yes, so what is your x? at center. How much is this x distance? If you're calculating the magnetic field at this point. Okay, we will understand. Oh, so we have written in the chat. Yeah, 0, 0. Yes, absolutely correct. So your x would be 0. So magnetic field at x equals to 0 is a circular full circle at center, right? So how much would be that? This would be mu naught r square 2. This is 0, so r square 3 by 2. So you will get mu naught I r square 2r cube. So this will cancel and you get the result that you have, right? Yeah. So this this part we will understand it next part. But yeah, I will talk about this thing we will understand later. Yeah. So we have, as you were asking, that we have other things other than the center. So we can calculate at different points also. Yeah. So please note down these things, and then we will do some question based on. We'll do a very simple question based on this, and then you guys, yeah, so then we'll do some tough questions. Whenever you guys have noted it down, please. Yeah. Okay, so it's Tarif. It's Tarif. Oh, Tarif, you are here. So I thought you got disconnected. You guys, please note it down, and we'll do a simple question and then
You can scroll up.
scroll up. Oh, yeah. Yeah, whenever you guys have noted it down. Yes, noted, Tariq.
The 1 minute.
Okay. Chavez, we have noted here. So wait, just wait for a moment for Tariq to sit down. In the next class, I will talk about the force, right? Magnetic force, and then I will talk about the force between two parallel wires, and then then I will talk about one more topic and then end this chapter. So next class will have this chapter. Then EMI and what is DC and those things will take. What discuss? Yeah, whenever you guys have noted it down, that
Yes, students.
okay, so please note down. Yeah, whenever you guys have completed it down. Yes, done, guys. Noted it. Yeah, Chavez has. What about you? Yes, Tariq. Tariq, noted. Are you there? Yes, Tariq, can you hear me? Yes, hello, Tariq. Can you hear me?
Yes, students.
Yeah. Okay, so let us do a very simple question and then we'll go some complicated question. The question is, that we have this kind of thing. So this is the Y. The current is flowing like this, and we want to calculate the magnetic field at this point. Right, this is the center. So this is R, and we want to calculate the magnetic field at this point. So how many contributions would be there, guys? How many contributions would be there? Let's say I current is there. So how many contributions? Chavez is saying three. What about you? Tarif, what about you? Shavin is saying three contributions. Yes, Tarif, what do you think?
Yes, sir.
How many contributions would be there at this point?
So four contributions, I1, I2, then I3, then I4.
Or I can see this one straight wire.
Yes,
I
sir.
can
Then that
see
curved wire.
this is
So then is
semicircular.
but is split into two, right? Yes, it
Yes.
will be four.
So then this three. So I'm seeing three wires.
Also, the semi circular is one is a single wire.
Yeah, yeah. This semicircular is one, right? Yeah, Shavi is all
I
right.
thought it was split.
No, no. So this one is single one, right? This one is a single.
Okay, sir. Thank you, sir.
So we have one, we have two, we have three contributions, right? So there would be one magnetic field, two magnetic field, and three magnetic. And you see that these are straight wire. One and three are straight wire. And these are along, so we are calculating the magnetic field along this line. So if we calculate the magnetic field along this line, so what is the magnetic field? Sorry. If we have this current and we want to calculate the magnetic field along the line, so what is the magnetic field at this point? This we have understood. I have, so yeah, I have written this, yes, right? If we calculate the magnetic field along the line, so that is zero, right? Tarif, is that clear?
Yes, sir.
So for this wire, we are calculating the magnetic field at this point. This is along the line. This is 0 for 3 1 along the line again. So this is 0. So only this will contribute. And this is a semicircular wire. This would be mu naught I, and this is capital I. It is phi 4R. And what is the direction? If we use the uh, Maxwell's rule, thumb rule, right? So what would be the direction? What would be the direction? Inward or outward? Yes, Tarif and Chavez. Inward or outward? Yes, guys. If we if we curl our finger, right, the direction of the circular semicircular wire. So what is the direction the thumb is pointing? Inward. So Chavez is saying inward. What are you saying, Tarif? Are you agreeing with this answer?
Yes, sir.
Okay, so this is correct. So you guys please note down this part and we'll stop it here. And in the next class, we'll do combinations of circular wires and straight wires. Something like this wire we can do, right? And all these kinds of wires. Yeah, you guys please note down this part. And I will send you guys some homework. So you guys please try that question. Yeah, Chavez, you have noted, yes. Whenever you guys have noted, please tell me. And if you have noted Chavez, then yeah. So if you want to leave this, Allah Hafiz, Chavez. Yes, Tarif. So whenever you have noted it down.
Yes, ma'am. So there's a homework.
Yes, what?
Is this a homework?
No, no, this one I have already told you guys. I have
Okay, sir.
already written the answer, right? And so whenever you have noted it down, Yeah, noted, Tariq.
1 minute noting it.
Yeah.